Hi, last class I had you work on exponential functions as a review, and then you worked on a logistic model. So exponential functions are great. That's what we typically use for population growth or financial growth or doubling that happens when cells grow or radioactive decay. That's a simple way to look at growth. However, it doesn't always work, because if you look here at my exponential function on the left, you'll see that it grows and grows and grows and never stops. Well, eventually you're going to run out of money. You're going to run out of resources to feed a population, and you're going to run out of people to infect in a disease. So a more accurate and better model for that is called a logistics function, and that's the shape of it. It looks kind of like an S, and that's what the graph resembles. So a logistics function has a parent function just like exponentials do, and quadratics and linear functions. And the parent function for a logistics function is f of x, or y, equals c over 1 plus a times b to the x. And generally you have to fit your model to whatever your situation is. C here is really important. That is it's called a carrying capacity. And that number is whatever your limited resources are. So, for instance, if we had an outbreak of an illness at the high school, there are roughly 1,600 people at the high school. Our carrying capacity would be 1,600. So that is information you would need to know. You'd need to know the population of something, and that would be your C value. And then you would need to know a few other points, and you could solve for A and B. If we look at this graph here, I have a graph of a logistics function, and I also have the equation for it. You'll see that the carrying capacity is 2. And if we look at the function, you can see that it has an asymptote to it. It never quite gets to 2 because it can't go more than 2. And then if you look down here, you'll see that from here to here, it increases quickly like an exponential. And from here to here, it's still increasing, but it's increasing at a decreasing rate. And another way to put it is from here to here, from on the negative side of the x-axis, the function is concave up, and on the right side of the x-axis, the function over here is concave down. So those are probably terms you haven't heard since Algebra 2. All right, so let's solve for our first model. We have a rumor spreading at a school that has a total student population of 1,200. 4 people know that the rumor, sorry, that's my door, it locks by itself, and someone just left the house. 4 people know that the rumor when it starts, and 3 days later, 300 people know the rumor. About how many people in the school know the rumor by day 4? Well, first, right off the bat, we can see that our C value is 1,200 because that is the population. Now we need to solve for A and B. But we need to look at what information we have that will help us. We know that when initial time, 4 people know about the rumor. So initial time is usually 0. No, it's always 0, and because we're starting something, and that the y value is 4. That's the number of people who know. And we also know that 3 days later, 300 people know. Wow, that's a lot. Okay, so we can go ahead and use this information here up top that I have to help us find the model for this. So I'm going to say, we're going to solve for A first. We always solve for A first, and you'll know why in just a moment. If I go back to my equation, here, I'm going to be putting in a 0 for x. That means that y is equal to 4. When x is 0, y is 4. And we already know that c is 1200. All right, so the reason that we always solve for a first is right here. If we look at this, any number to the 0 is what? It's 1. So I don't have to worry about that. And I actually end up with 4 equals 1200 times 1 plus 1a, because b to the 0 is 1. Any number to the 0 is 1. And that's why we always solve for a first, because we can get rid of 0 or b when we plug in the value at 0. So I would multiply both sides of my equation by 1 plus a, because that's going to cancel out. And I'm going to end up with 4 times 1 plus a, need to protect that with parentheses, equals 1200. And then I'm going to divide by 4. And that leaves me with 1 plus a, because the 4's are going to cancel out. That's the whole point of that. Equals 300, which means that a is equal to 299. Great, now all I have left to solve for is b. So I'll go back and I'm going to use the second value that I have, the one where x is not equal to 0, and I'm going to plug in the values I have into the equation. So when x is 3, I know that y is 300, c is always 1200, a is 200, and x is now 3. Okay, I'm going to multiply both sides by this denominator here so that I can move it. And then I'm going to divide both sides by 300. And that's going to cancel out. It's going to leave me with 1 plus 299b to the third equals 4. Subtract the 1, and that equals 3. And then I'm going to divide by 299, and that means that b to the third is equal to, let's see, in my calculator, I'm rounding here, 0.0100, and then I need the third root of that. So I'm going to raise both sides to the 1/3. And I do that by, in my calculator, 0100, use the caret thing, parentheses 1 divided by 3. The reason I do that is b to the third to the 1/3, you're raising 3 to the 1/3 power, gives you b to the first. That means that b is going to be about 2.216. So you're going to need a calculator for this. And then I have everything I need for my equation. I have y equals 1200 over 1 plus 299 times 0.216 to the x. X and Y stay as variables in my final model. And now to answer my question, how many people at school know the rumor by day 4? I plug it into my equation. I don't know why. I'm trying to find out how many people. And I do know that the day is day 4. So this is really important too. Hang on a second. I need to do this in the proper order or I'm not going to get the right answer. So I do 0.216 to the 4th. Whatever I get there, I multiply that by 299. So this is first, this is second, and then finally I add 1 to it, and that's third. Whatever number I have there, I take 1200 and divide by that number. My final answer, oops, I need a marker, not a highlighter. My final answer was y equals about 729. I'm always going to round up. Can't have a part of a person. All right, example 2. So here I don't have a word problem. I just know that C is equal to 12 here, and that I have 2.09 and 111. Going to go and get my model, my parent function. All right, I know that C is 12, so I can go ahead and plug that in. That should be first, C. CAB, like cab. All right, and then I'm going to use my point here, 0, 9. I need to use the one with 0 so that I can solve for A. So y is 9 when x is 0. All right, this cancels out. That's 1. So then I have 9 equals 12 divided by 1 plus 1a. Now multiply both sides by 1 plus a. And then I'm going to divide both sides by 9. So that means that 1 plus a equals 4/3. And then subtract 1 from both sides. A is equal to 1/3. Subtract the 1. Okay. Now I can go ahead and use my second point and plug that in for x and y. I'm actually going to move over here. So when x is 1, y is 11, c was 12, a was 1/3, and b is 1. Oh, this one's going to be easy. I'm going to multiply both sides by 1 plus 1/3 b. b to the first is b. So I get 11 times 1 plus 1/3 b equals 12. I'm going to divide both sides by 11, and I get 1 plus 1/3 b equals 12 over 11. Subtract the 1, and I end up with 1/3 b equals 1 over 11. Multiply by 3 over 1, and b is equal to 3 over 11. So my model here, and if you use decimals, that's fine. Just make sure they're equivalent. So the model I end up with is y equals 12 over 1 plus 1/3 times 3 over 11 to the x. That's the model for that one. One more example, and then I'm going to send you off to do your work. Okay, so determine the model given by c equals 7 and the points 0, 2, and 3, 5. Well, right off the bat, that c is 7, and I'm going to go ahead and replace that. And then next, I'm going to use the point with the x is 0 so that I can solve for a. So when x is 0, y is 2. Don't forget to do that, or you'll be like, I don't know what I'm doing. I can't do it. I've done that before. And I'm like, oh yeah, you have a y value. So b to the 0 is 1, so I can go ahead and cross that out. Not cancel it out, cross it out. So I end up with 2 is equal to 7 over 1 plus a. I multiply both sides by 1 plus a. And then I divide both sides by 2. And then I can subtract 1 from both sides. And I end up with a is equal to 5/2. Or I could call that 2.5. Whatever floats your boat. I think in the end for this one, I think it's better to put it in decimal. All right, so I know what a is, and I am going to go ahead and plug that into my equation. And I'm going to use my second point, 3, 5. When x is 3, y is 5. And I'm going to plug in all my other known values. Let's see, x is 3. All right. So I have 1 plus 2.5 b to the third. B is the thing I still don't have. And if I multiply both sides by this 1 plus 2.5, b to the third, so that I can get it out of my denominator and work with it more easily, then I can divide both sides by 5. I can subtract 1 from both sides. And then I can divide by 2/5. I'm sorry, 2.5. And I get 0.16. Now all I need to do is clear that cube there. So I'm going to raise both sides to the 1/3 power. And again, it is 0.16 in your calculator. It looks like this, 0.16 caret parenthesis 1/3. That's what it's going to look like. All right, and that gives me a b value of about 0.543. And that's why I had to change that one from fractions to decimals, because you shouldn't have fractions and decimals in the same problem. So my final answer is going to be y equals, or f of x, whatever, 7 divided by 1 plus 2.5, that's for my a value, and 0.543 for my b value, to the x. And that's it. Now I have some practice for you to try.